What's going on, guys? So I got another one. 05 Scion XB 1.5 1NZ FE engine. So customer states the red battery light is on, the yellow VSC light is on, vehicle stability control, the yellow track off light is on, that's traction control off, and the check engine light is on. Car shut off while at a stop. The VSC and the track light are very common to go on as well with the check engine light. So you set a misfire code, you set any code like we have today, it'll set all three lights. That's just basically a normal check engine light, and it's disabling traction control when it throws that check engine light for some reason. Toyota likes to do that, I don't know why. So regarding battery light on and car shutting off while at a stop, that sounds like a separate issue. So it sounds like we got two separate issues today. Regarding the car shutting off and the battery light on, sounds like a separate issue. So it seems like we got two issues going on with this car. So we'll find out. But the first thing we do is a code scan where it scans all the modules. It detected three modules. The PCM, the TCM, and the ABS module. Airbag, I cannot say, but there's airbags in here, obviously. So, do the code scan, and it basically detects one code, and it's in the engine and trans module. So in the PCM we have current code. See, engine current. The next page down is ECT circuit low input P0117, and it's also in the history, kind of redundant history, and it's in the pending for the trans. So very redundant. Toyota makes you, here's the code, it's in your face. Verify the complaint. So I do have a battery light on. So we do have two issues. We have a code and a battery light. So we'll the battery light's gonna be a lot easier. So we'll do that first. Do a VAT check with the picoscope. Probably see the alternator's not working, and then we'll look at the diodes with AC coupling and call the alternator most likely, and then check the code out after that. So let's get to that. Grab the pico. Have the leads around it, but I haven't hooked up yet because I've been using secondary leads lately. Alright, so these are just regular voltage leads. So we're gonna have one channel with volts. It's all hairy and dirty. And of course I'm out of this. And then we need an amp clamp on a wire. It's not going to be the positive side because I can't get around them all. So we'll go around the negative because I can get around both of them. Current out must be current in. Kirchhoff's law, Watt's law, one of those. But there is energy used as it travels, so I've put an amp clamp on injectors or whatever on both sides, and it's not the exact same, but it's very, very, very similar. $2,000. When you hit it into the mode, it's zeroing it right now as we speak, so I'm not gonna open the jaw. So current is conventional flow, so positive going out, so it's going in on the negative side, so we'll have it towards the battery. Ready to go. I just need battery temp. And we are dealing with Celsius because Pico is in the UK. Trying to get an average because it's all over the place. I'm gonna call it 20, 21. It's going 15, 25, 20. I saw 19. Boom. So there's Pico automotive scope and there's Pico diagnostic software. Do the diagnostic software. Battery test. Oh, cranking amps. I hit it 550. It doesn't really matter, but temperature 20 degrees. I'm gonna leave that. That's pretty accurate. So start, and it's already measuring battery voltage. Key was on. Cause I'm done. We're charging at 10 amps. We're not charging though, it's higher, so that means it's being used. See how the starter motor took current? So we're not charging, we're using 10 amps. And yeah, see, 11.9, 12 volts, waiting for charging. It ain't gonna come, dude. Yeah, status, not charging, 11.9 volts. Lowest drop, 725, 724. So I'm gonna recharge the battery while it's disconnected. But before we do that, there's two things to do. I don't hear anything, so we'll look at the diodes real quick though. Normally you'll hear a whining noise and you'll check the diodes and you got a bad open or shorted diode. So I'm gonna save this. So ironically, the connector color wires are blue, red, and yellow. So where's my scope? Blue, red, green, yellow. So I'll put the green channel on the output terminal of the alternator, and then the wires, I'll just use the back probes for the regular channels. Blue, red, and yellow. Well, all good. All of them. Red to red and blue to blue. Then I'll put my clamp on. Clamp on the green, and then clamp it on to the output terminal nut. So close the Pico diagnostics program. Then you can open the scope program, and I need a ground lead. When you buy the AES Wave, the test drive, the Varus test drive kit, it's basically Vantage or Varus leads. They are Pico leads with banana jacks, and then when you buy them, they come with this little tail I really like. We should have a power, and one of them is going to be grounded for the light, and the other one, I'm not sure. It might be a power in, sense, and the light. That's usually how it goes. So green, I'm going to change to, so it's on 1X, 1 times, but they're always on DC. I'm going to switch the green to AC. That's AC coupling. So now we're reading AC voltage, and we'll see the diodes. So key on, see what happens. So key on, I got yellow and blue with some data, and green is flatline, 0 to 12 volts. So it's like some pulse width action going on there. So if I had to guess, yeah, res 12 volts. So I'm gonna turn this on real quick. Yeah, key on, started it, voltage dropped, we're running. So I got pulse, I got action on everything, and the diodes don't look bad. Not really seeing much in them, to be honest. Yeah, diodes don't look funky, they're calm, if not dead. Starting charging system, one diagram, very simple. Okay, so here we got the alternator on the bottom, and we got black, red, red, black, yellow, green. They don't show the blue wire, huh? Regardless, yellow is L, that's the light charge indicator. So we know that one's supposed to be grounded out, and that's probably, it's pulsing it out. And I believe I know it was being pulsed, and I think what it was mainly grounded, and you see a pulse going up, letting it go. So it's like a duty cycle, like a 90% duty cycle, 99.05. So yeah, this is very fast, but the yellow is grounded and it lets it go for a second, lets it go for a second, lets it go for a second. That's a 99% duty cycle, call it 99, 98. Right there. That's the yellow. Ignition, red. Right from the ignition switch to a fuse to that. So that tells me it shouldn't be pulsing. There's no reason for it to be pulsing like it is. If we look at the red, right here, key on, it was solid. For some reason you get a little blip. But then you start it, and once it's running, it's dropping out, and it's looking bad. So it's going open inside the alternator, it seems like, but very consistently. So I bet you with a new alternator, it's going to be consistent. I don't see a reason for pulsing, at least in this wiring diagram. Could be wrong though. And then this is the always hot big output terminal wire. From alternator fuse, 120 amps. We obviously know that's good. We have, well, actually we don't know it's good. We had diodes on there, but I will hit it with a test light real quick. And then the green black, oh, that's my blue wire. Yeah, green, black, or blue. Alt from the ECM and the PTC amplifier. We know blue had good duty cycle, consistent, so that wire's good. Just so I could say I did it, because that was kind of silly. Test light up, and there we go. There's that light. It's only a couple hundred milliamps, but we're connected, loaded with some little load. So, using alternator, let's start with this 117 now. So alternator just came, and right before it came, I was going through some of this stuff, wiring diagram, code setting parameter, conditions, factory, wiring diagram. But what I just noticed, or just realized, is This could have set when it stalled, essentially. No beating around the bush, but voltage was so low from not charging. Let's say it got down to 8 volts and the computer just went, I don't even know what's going on anymore. And I noticed earlier when I moved the car from the lot, the blue coolant temp light on. So that means it's warming up, it's still cold. So that means the temperature is being read correctly. So data, I'm gonna see it around probably 70 degrees right now if I had to guess. Didn't move it too much, so maybe, I'm gonna say 60 to 100 degrees. Engine data. Coolant temp, 84 degrees. So let's, engine speed, coolant temp. Let's watch it bump up a couple degrees. So we're at 84. Start it. I'm gonna give it like 2 grand. Make it go faster. Boom, 86. Let it go to 88, and I'm gonna call a working sensor. Everything's working right now. Okay, 87, that's fine. I'm not gonna let it warm up too much because I gotta do it all. 89, 91, I'm gonna shut it down. I gotta do an alternator still, but ECT is working. That's an effect, and the cause is the alternator. So this is just gonna be a 1-part video on the alternator, I guess. And this is a good real world example of stuff that happens from other stuff. So check engine light and all that stuff derived from failing alternator. So I just got the alternator. This is all good. So I'm gonna call the customer, get the okay to install that alternator, and I have it ready to go. This customer is a good customer and will more than likely okay the job. Well, there's been a new development. So we're running, we're idling, but the belt broke. It's flat down there, so no wonder we ain't charging. Yeah, I went to look at this to see what tool I needed, and I saw the belt was loose. I'm like, what the hell? So she done. It's a 4-rib 404/76. These are deep grooves. So they basically just get so deep, they get thin and snap. All right. Well, back probes are still hooked up, then disconnected, so we'll see what it's supposed to look like after with a new belt. So I got the belt off. She done. Well, actually, we are in the right direction. This alternator is locked up. She done. And tech tip. So when you're doing this, you have this wiring harness. You move that out of the way. So there's only one thing though. You got the solenoid right here, VVT. You got the connector, the output terminal. This guy, this leg right here, be careful. That goes down to the crank sensor. If you tug on this too much, if you're too rough with it, you're gonna put an alternator, a belt, you're gonna do whatever the hell you wanna do. You're gonna go ahead and get back in it and it's not gonna start because you ripped the wires out of the connector. So be careful of that crank sensor. One of these is not like the other. Look at that shiny new Denso alternator, just like the good Lord intended. So left all our hookups the same. Loaded up the old file, so all I gotta hit is start and it runs by itself. The bulb check, key on. See, the battery light is on and it's staying on. That yellow, I forget what color it is. Yeah, yellow, right there. It's key on, it's off. Key on, and it goes from negative 24 millivolts, bumps up to 634 millivolt, 635 millivolt. So that is a good ground, and it is grounded because the light is on. So I'm gonna save this as just a key on. No battery light. And what you'll see, can't see it now, but the yellow, it gets grounded for the bulb check and even during cranking. But as soon as it sees more than 12 volts, probably 12.5, it shuts that light off. It must see something else, because it shuts the light off at 10.24 volts. 10 1/4 volts is not charging, obviously. And then we got diode life now. Oh yeah. Diodes look beautiful. Record live. And now I'm gonna change it from AC to DC. So now it's a voltage monitor, not just a diode monitor. Green key on is 12.6, and then charging is 13.96. And then for the last thing, trade you. Current towards the battery because it's coming in. Temperature 17, 18, I'll go 17.75. Keep it the same, 550. Start 12.7 volts. And current was 0. And you remember current being used was higher. So now we see current gets used from the starter motor and then it dips down because the alternator charges. And now we're working. I'll do it again for live number, but 33.6, 13.8 volts charging. We hope I could capture, it tells you the live number of the charging, and it'll be in a negative number if it's charging, because reference back to when it's not charging, it's a positive, I think 10. So I'm gonna hit start. See how it's 0, 1. So I'm gonna try and catch this. Negative 30, negative 25. That's it. That's it. She done. She fixed. And she's shipping. No lights. We're good. Another one in the books. Thank you guys for watching. Diagnostic Dennis out.